Okay. So last class we have discussed constructors. Let us proceed from that. Yes, I believe we have gone through naming convention in Java also. Okay. Encapsulation also we discussed. That is binding the data into one entity. For us, the example of class which we discussed can be treated as an encapsulation example. Then let's move to inheritance concept. So we are discussing object-oriented programming concepts. Under that, class object we have finished. Encapsulation then. Now we are looking into inheritance. So under OOPS concepts, class object example, encapsulation, inheritance, then polymorphism, abstraction comes, and we will discuss those things possibly today or in next session. So to begin with, inheritance. So inheritance. An object can inherit properties from another object. The inheritance which we see in human beings, like children get properties from their parents, grandparents. So similarly, here also one object can inherit properties from another object. Child object can inherit properties from parent. And here we use a keyword called extends here. Ext and s extends is the keyword that denotes inheritance. That is, child is extending properties from parent. And this inheritance concept is used to reusable. That means the code can be reusable. Here you can see, assume there is a class A and class B. So class B can be treated as child class and class A can be treated as parent class. Then child is inheriting properties from parent. So let me discuss one example, then we'll go back to how to write this code, this part. So here you can see I have listed an example of a vehicle class. So here under vehicle class, the characteristics of vehicle would be like seat, color, engine, belt, wheels, fuel, body, make, model, steering, brakes, clutch, etc. All these comes under characteristics of vehicle. So here all those characteristics can be represented for this vehicle. And this is the vehicle. Assume I would like to represent a two-wheeler vehicle. Then for two-wheeler vehicle, the properties would be similar. That is, seat. Two-wheeler also has a seat, color, engine, belt, wheels, fuel, body, make, model, steering, brakes, clutch, etc. So my two-wheeler class can have all the properties that are listed in vehicle. Also, two-wheeler can have two-wheeler specific properties, like the number of wheels would be 2. So here two-wheeler. So for example, motorbike. So all the inherited properties from vehicle plus specific properties to two-wheeler. So here two-wheeler, all these are the properties. So color, engine, why you have mentioned air over there. Mm, Color, engine, wheels, fuel, body, make, model, belt. So here the thing is, for two-wheeler we will be not having any belt, whereas for four-wheeler like car and some bigger vehicles we have seat belt. So I'm talking about seat belt. Steering, so two-wheelers will not be having steering. They have handle kind of thing. So like this, the properties would be specific to two-wheeler. Similarly, if you want to talk about three-wheeler, then three-wheeler also will be having the properties that are listed in parent as well as some specific properties to three-wheeler. So color, engine, you can see here all these are inherited property from parent. So of course, three-wheeler also may not be having belt. Steering, there will be, I mean, I'm talking about an auto rickshaw. So steering, it does not have steering. So there may be some specific properties to three-wheeler. So the major thing to be noticed here is we can define a parent class with a list of common properties present in it. Then two-wheeler, three-wheeler, four-wheeler, all these are derived classes from vehicle. So these derived classes can inherit properties that are present in the vehicle and also can have these two-wheeler or three-wheeler specific properties. So here vehicle class acts as parent and these two-wheeler, three-wheeler classes can be treated as children. So when we go back to how we represent this is, so here you can see I have labeled the alternative names for parent class and child class. So here class B and class A. So class A. So class A can be treated as parent. So when class A is called as parent, then class B, which is inheriting properties from class A, can be called as child class. So here child class is extending properties from parent. And the parent class can also be called as superclass. In that case, the child class is called as subclass. So the parent class can also be called as base class and the child class can be called as derived class. The parent class can also be called as old class and the derived is known as new class. So these are the corresponding terminology which we refer to. So here in Java, so how do we represent this class A and class B? So here you can see class A, open brace and close brace. The set of statements go here. Class A's, that is characteristics, maybe member variables, member methods. Then child class. So child class, class B extends A. Here you can see we are establishing a relationship between class A and class B by using the keyword extends. Extends what? Parent. And here goes the list of B class specific properties. So here when class B is extending from A, then all the properties of class A are visible to class B and can be used in class B. So that is how we represent in Java using extends keyword, and these are various alternate terms we represent parent class and child class. Yes. So I am considering an example here. So example here you can see animal. So I am treating animal class as parent class and mammal as child class. Here I have introduced another class dog, which is extending from mammal. You can see that is animal is grandparent, mammal is parent, dog is child. So in animal, I have labeled the general characteristics of animal, that is eat, sleep, run. And mammal is inheriting from animal. And mammal is having specific property of mammal, like mammals give milk. So gives milk is the specific property of mammal. So along with that, there will be eat, sleep, run inherited properties for mammal. And for dog, so bark is specific property of dog. Along with that, dog is inheriting from mammal, so it gets a property gives milk. And dog is inheriting from animal, grandparent, so it gets properties eat, sleep, run. So I'll write an example and I'll show you that mammal is inheriting properties from animal and dog is inheriting properties from mammal as well as animal. I'll show you by an example and let me open Eclipse. So here I'll create a class animal, then list out the properties under class, then I'll create a parent class, that is mammal class, and mammal would be extending from animal, and I'll show you how these properties are inherited by writing some members in both animal and mammal class. Yes, let me create class. I am naming the class test drive inheritance. Yes, so this is my class, and above the class here I am creating a parent class. My parent class name is animal, and I am listing the properties here. So the properties are eat, sleep, run. So I just mention I eat, and I am writing a simple statement system.out.println, and here animal eats. So this is the animal property. Similarly, I write eat, sleep, void sleep, and here I write system.out.println animal sleeps. Similarly, third property, void run. SYSOUT system.out.println animal runs. So I have defined the parent class here. Now I define the child class. So you can see here animal class begins and closes here. The brace is highlighted. Now I go down here, write another class, create child class. So class mammal, And this child class is inheriting property from animal, and that can be represented using keyword extends animal, and of course my class goes here, and here mammal will be inheriting the properties from animal, and here I am labeling mammal specific property, that is mammals give milk. So I write gives milk. So inside this simple SOP statement mentioning that mammals give milk. I am done. I have labeled subclass specific property also. So we have two classes. One is animal parent class with properties eat, sleep, run. Then I have mammal class which is extending from animal, and mammal also has gives milk property which is specific to mammal. Now inside my test drive inheritance main method I am doing create an object for parent class. Parent class. How do we create the traditional way? Animal object equals to new animal object. So dot. Of course, when you mention dot over there, the Eclipse will show you all the properties that are available for animal. So eat. If I choose eat, now I execute this. So when I execute this, when this particular statement gets executed, you can see eat method. So what happens is JVM goes into eat method and executes this eat method, displays animal eats. So let me run this. Yes, you can see animal eats. So it means that I can create a parent object and access the properties that are present in the parent. Similarly, I can access all the properties animal object dot eat sleep semicolon. So when I execute this, it will show animal sleeps. Let me save this. So here go. You can see second statement is animal sleeps. It means with the parent class remote control, we are able to access the parent properties. Yeah. Now, so similarly, you can try with run method also. So now what I am doing is go create an object for child class, that is mammal. So that is mammal object equals to new.
Yeah. Sorry. Hi. I'm able to hear now.
Okay, fine, proceed, Mahbub.
Yeah. Yeah. Yes, please.
So mammal object. So by using mammal object, now when I give dot over there, Observe, yes, when I give dot over there, the Eclipse content assist is showing each method is also available with mammal, and actually each method is from animal, we can see animal. And similarly there are other methods. So let me highlight use milk. Use milk method is also available to mammal object, and it is from mammal class. Run from animal class, you can see. Sleep from animal class. And there are other methods like equals and get class, notify all, hash code, toString, wait, overloaded method, wait, another overloaded method. And you see, all the other methods are actually inherited from object object class. I will talk about this object class also. For now, what I'll do is, let me go, I'm using run method on mammal object. Observe, run method on mammal object. Mammal object actually has, so let me go. So what happens is JVM will try to access run method from mammal object, and it goes here, look for run method in mammal class. Look for run method in mammal class. In mammal class, where it begins here, closes here, it does not have any run method physically available. Then in that case, mammal is extending from animal. So immediately JVM will get into this parent class. Is there run method available in parent class? Yes. Then it executes this. And when I execute this, it will display animal runs. So this statement will prove that the parent properties can be reused, and mammal object is inheriting run property from animal. If you want, you can access mammal specific gives milk. And when I execute this, it will show mammal gives milk. Mammal gives milk. So similarly, if I introduce another dog class, that is grandchild, create another child class, better say grandchild, sorry, grand. So I write class dog extends, now extending mammal. So dog specific property I can label here, that is dogs bark. Why bark? System.out.println and dogs bark. I save this, get into my test drive main method. So first I'll create an object for dog class. So the traditional way, dog object equals to new dog. Using dog object dot, so you can see directly you can go for bark. And when I execute this, it will display dogs bark. And I can access immediate parent behavior using dog object control space dot immediate parent is mammal. So I can use goose milk. So dogs are also mammals. So when I use this, it will display here on dog object, it gets into dog controls. That's all. So JVM will get into dog class and look for use milk method physically. No, not available physically. Logically, it is available because it is extending from mammal. It goes to mammal. Yeah, here goes use milk and it will execute this and prints mammals give milk. So I execute this. Mammals give milk. Similarly, if you want, you can access the parent, that is grandparent. So what I'll do is Control C, copy, paste. So access next level parent, that is grandparent can, that is dog object control space dot I say sleep from animal, right, and enter key, save this and execute this, will display animal sleeps here. From this example, it is clear that child objects are inheriting property from parents. Let me go back to Notepad. So here, in my example, so there are grandparent, parent and child. And here, the child is extending from mammal. So here, you can see, I am talking about a relationship called is a relationship. One of the important interview questions is a relationship. Dog is inheriting properties from mammal. So, dog is a mammal. Dog is inheriting properties from animal. So, we can call dog is an animal. So, that is dog is a type of mammal or dog is a type of animal. So, subclass is a type of superclass. Subclass is a type of, so here, even here also, mammal animal also. Subclass is a type of superclass. So here is a relationship. So is a relationship can be uh, described when there is an inheritance relationship between two classes. So similarly, we have has a relationship. So has a relationship is something like one object is constituting another object. For example, if you say our real examples like in our house, so there will be various rooms. So dining room, kitchen room, so bathroom. So here in dining room, if you say again, there will be stove. So sorry, in dining room, yeah, in kitchen room there will be stove and maybe some other objects like knife, vegetable chopper, all those things. So everything is treated as an object over there. So I can say kitchen room has stove in it. So kitchen room has a cylinder cabinet in it. So cylinder cabinet also can be treated as an object. Similarly, I can say bathroom has water tub in it. So bathroom has. So it means water tub is present inside bathroom. Similarly, in kitchen, stove is present inside kitchen. So that is has a relationship. So over there, one object is having the other one. If you refer to our example, yes, here, which I just wrote, here I have established the relationship between parent and the child using the keyword extend. That is, child is extending from mammal. If you go into test drive inheritance in main method, observe there, test drive inheritance is another class. This class has animal object. You can see has the relationship over there. And this test drive inheritance has mammal object. Similarly, test drive inheritance has dog object. So that is what has a relationship is. So for has a relationship, you don't need to have those classes participating in inheritance. So whereas for is a relationship, there should be inheritance. Without inheritance mechanism, you cannot say one class is a type of another class. So sometimes in interview they may ask you about what is a relationship example and has a relationship example. So I am going further talking about OOPS concept abstraction. So abstraction is another OOPS concept. So under OOPS concept we have covered class, object, encapsulation, inheritance. Now we are looking into abstraction. Abstraction.
Sorry, just a question.
Yes.
Hello.
Yeah, yeah.
Yeah. About the has a relationship, you show that if we define an instance in a class, so is that how we define a has
Yes.
a?
Right, right.
Uh,
Absolutely.
okay.
Fine.
Right.
Okay, okay.
Thanks.
Abstraction. I'm talking about abstraction. Abstraction. Showing the essential things by hiding the unnecessary details. So this is the definition of abstraction. That is, we are going to show the essential things and by hiding the unnecessary details from other objects. So for example, let me give a real-time example like a uh, suppose you are driving a car and the car is in motion. Now, if you want to take left direction, in that case, you will be moving your steering, rotating your steering towards left direction. Then the car moves to left direction. Similarly, if you want to take a right turn, then you will be rotating your steering to right direction, right side. So then that is clockwise. Then your car would be moving towards right. Suppose if you want to stop your car that is in motion, then you apply brakes over there and immediately the car stops and comes to rest. So over there, the car which is in motion, so you control the car using steering and brakes over there. So when you are applying brakes, that is, you are just resting on your brake with your foot and apply some pressure. So that is you are pushing the brake with your foot. So here the driver is caring about the footrest over there, brake, and he is resting on the brake and he is just applying some pressure. Internally, what happens? The car which is in motion, when the driver is applying brake, that brake is internally connected through some rods and those rods are again connected to tires of the car and over there some pressure is being created when you apply brake and the car which is in motion slowly comes down. So, like Newton's laws of motion, for every action there will be an equal and opposite reaction. So when you apply a brake, so it is internally creating some pressure on the tires, and the tires which are in motion are slowly getting down to rest position. So some physical, physics related, some mechanical related things are happening when you are applying brake, and similarly when you are rotating your steering towards left direction or right direction. So for us who are driving the car, steering and brakes are important for us. Rest of the things like physics and mechanical related formulae, what are happening inside the car internally, we are not bothering about that. We are bothering about only whether there is a brake or whether the steering is functioning properly or not. So here, the car manufacturers are showing the essential things like brake, steering for us, and when you use them and when the car is in motion, internally these physics related, mechanical related things that are happening are hidden from us. And we also don't care about that. So that can be treated as an example of abstraction. So showing the essential things by hiding the unnecessary details. So here, abstraction generally its meaning is unclear, incomplete. That is English meaning. Here in Java, we represent abstract using the keyword abstract. And this abstract keyword can be used with methods and classes to denote which. So what happens when we use abstract keyword with methods? Then methods become incomplete. So how do we say that a method is incomplete or complete? So generally while writing a method definition, so let me show you method definition. You can see I have mentioned here methods, eat, sleep, run, bark, all those things. So let me take bark. So I already showed you method with the method name, return type, and here goes the body of the method. So if a method is incomplete, then those methods will not have a method body, and those methods are known as abstract methods. I will show you by example, of course. So here, when we say methods are incomplete, that is methods are abstract, it means they don't have method body. And when we say classes as abstract, then classes are incomplete, they are not full. So I will show you by example by referring to our animal, mammal, dog hierarchy, which I already executed a sample. So in my case, what I am doing is this abstraction also is involving inheritance in it. So let me write, yeah, go here. I create another class here. I am making use of that animal, mammal, dog. So go new class, test drive inheritance. Sorry, abstraction. Abstraction. So, with main method, finish. And here I will write the class animal here. So parent class animal. Observe there when I create class animal, it will throw an error saying that animal class is already defined in the same package. So here you can see animal class is already defined. So let me label it as animal 1. My animal 1 class now has, yes, properties, eat, sleep, run. So what I'll do is, of course, eat method, system.out.println, animal eats. So this method is complete. So complete method. So complete method has alternate name. Concrete method we call it as. It means method with method name, return type and method body. Now I am going to define some abstract methods here. Abstract methods in parent. While sleep. Look there, I am not adding any method body to this. Semicolon immediately. And it means that this method is abstract and it does not have method body. And here you can see there is an error. The method requires a body instead of a semicolon. So JVM is expecting, that is Eclipse is expecting, this sleep method should have a method body. It should not terminate with a semicolon immediately. So either you can add body or you can tell JVM that, hey JVM, please don't expect method body for this. This is an abstract method. So I need to tell JVM that this is an abstract method. Now I save this. Yes, sorry, abstract spelling, abstract. So here you can see there is another error. I marked sleep method as abstracting, denoting that sleep method will not have method body. Still there is an error. So you can read that abstract method sleep in type animal 1 can only be defined in an abstract class. So what it says is, you are, a programmer, you are writing a sleep method and marking it as abstract. And my class animal 1 is a normal class, better say concrete class we call it as. So a class with methods can called as concrete class. So you are defining a concrete class and you are mentioning an incomplete method in it. When a concrete class has incomplete method, that is abstract. Here sleep method without method body. In that case, the class itself become incomplete. So you need to tell JVM that my animal 1 class is incomplete. So how do we do that? We do that marking class as abstract. So now I save it. If I save it, and there are no errors here, you can see. There are no errors. So here one rule, that is, in a class, if there is at least one single abstract method, in that case, the class itself will become incomplete. In that case, you need to qualify the class name with abstract keyword. If you are not qualifying, JVM will throw an error mentioning that there is a method which is incomplete. It means that class is incomplete. You should tell JVM explicitly that my class is abstract, that is incomplete, by marking the class as abstract. So I am done. Let me define another abstract method. Abstract method, that is abstract void. So eat, sleep, run. So I marked run method also abstract. Yes. Now my animal class has one complete method with a definition eat. So we call it as complete method. And my animal 1 class has sleep abstract method, run abstract method, which are incomplete. Now my animal class 1, so animal 1 class is completely an abstract method, which means that there are methods without definitions. So here the thing is, so generally the classes should have method and method bodies. Only then we can create an object for those classes. We cannot create an object for incomplete classes. So here we cannot create an object for incomplete class. Animal 1 as of now is incomplete because it is qualified with abstract keyword. Then, so here you can see when animal has some complete methods and some incomplete methods, then methods without a definition does not make sense. They should be provide some behavior. So how are we going to provide that behavior? Here in this example, the animal one class is abstract. So we are going to provide definitions for these abstract run and sleep methods in subclasses. So here create a subclass mammal and provide definitions for incomplete methods. Yes, here goes class mammal extends animal one. So I already have mammal class in the same package, so JVM will complain. So I am giving mammal one. And here, yes, observe that mammal one is extending from animal one. Now it is throwing some error. Read here. The type mammal one must implement the inherited abstract methods. So by this definition, so class mammal one extends animal one, it means that mammal one class is concrete as of now. As of now, it is concrete. So as of now, it is concrete. When it is concrete, so look here, observe this. So here, mammal one is inheriting from animal one, and there are some unimplemented methods. I mean, there are some methods without a definition. So we need to implement them. So what I am doing is, I am trying to implement so here, implement, or better say, provide definition for sleep method. So here I am providing sleep void sleep system.out.println. So here I write mammal one sleeps. So here I am saving it. Of course, mammal one can have mammal one specific property gives milk. So gives milk. And here we can write system.out.println mammal one gives milk. Observe there, as of now, I have defined mammal one class extending from animal one, and I tried providing definition for sleep method. Now you can provide definition for run method also. Run is abstract. So here, if you provide definition for run method, then mammal one class is having all the methods with method bodies. In that case, the mammal one class becomes concrete. So assume for some reason I am not providing definition for mammal one, that is run method here. In that case, mammal one remains incomplete because mammal one is extending from animal one, And animal one is providing properties eat, sleep, run. Eat method is already having definition. Sleep method, of course, mammal one has defined for sleep, and run method for some reason I am not defining. In that case, mammal one becomes abstract, and we should tell JVM that mammal one is abstract. So here I marked mammal one as abstract. If you see mammal one and animal one, still there is a run method which is unimplemented, which is not having definition. So we should provide, how we are going to provide definition for that? You can provide definition somewhere down the line in doc class if you want. Create grandchild class. So here goes class dog extends mammal one. I have to write it as dog one because I already have a dog class. Dog one extends. So when I wrote extends mammal one, it will show that it is having an abstract inherited method, that is animal one run method. Animal one run method. Animal one run method. So you can tell add unimplemented methods to JVM, that is Eclipse, and here it goes run method. And here you can say system.out.println dog one runs. Done. And if you see here, a new @ override has been generated by Eclipse. We will talk about @ and override soon. As of now, you ignore. Then let me take you to test drive abstraction demo here. Here, try creating creating an object for animal one. Observe that animal one class is an abstract class. It means it is incomplete. For what reason it is incomplete? It has sleep and run method without definitions. That is why it is incomplete. If a class is incomplete, we cannot create an object for that class. If you try creating an object for such incomplete class, JVM will throw an error. So I am deliberately trying to create animal one object to show you that JVM will throw an object error. Yes, here goes. Cannot instantiate the type animal. Cannot create an object for type animal one. So that is the error. So what I'll do is I'll copy this error and paste here for your reference. And I'll comment even this line also because I cannot execute it as there are compilation errors. Similarly, try creating an object for mammal1 class. This also will throw the same error because mammal1 is also incomplete. I marked it as abstract if you remember. I am taking you up. Mammal1 class is abstract. So let me. So you can try this. It will throw an error. So here try creating an object for dog class. Of course can. Dog1 dog object equals to new dog. That is dog1. Yes, can, because dog is a concrete class, you can see. Let me take you up. dog1 does not have any abstract keyword and it is extending from mumble1. So mumble properties as well as run method which is unimplemented from animal1 class is giving definition here, and if you want you can add void bar which is dog specific property and say system.out.println dog barks. So on my dog object dot I can use bark, it will display dog barks. On my dog object I can say dog object dot run method, so which is actually present in dog1 itself. When I say it will display dog runs. Dog1 runs. Similarly on dog1 object, dog object dot so mammal use milk it will say mammal1 use milk. You can try on dog object sleep from mammal1. It says mammal1 sleeps. Mammal1 sleeps. Similarly, eat from animal1. Save this, run this. So here goes. So this is how we can create abstract classes and abstract methods by using abstract keyword, and I highlighted here those things. So so methods are incomplete. When they are abstract, it means they are incomplete and they don't have method body. And classes, if you mark classes as incomplete, they are not full and you cannot create, here you can see, you cannot create an object for the class. You cannot instantiate. So I write here, instantiation is nothing but the process of creating an object for the class. So this is another important interview question. Sometimes they may ask you what's the difference between instantiation and initialization. If you go back somewhere, I have spoken about initialization in variable declaration. So under variable declaration, so if you are defining a variable along with data type and provide a value immediately in this single statement, then this is known as initialization. Whereas instantiation, that is creating an object for a class, is known as instantiation. So initialization is providing a value for a variable in the same line, that is in single step. This one, this age equals to 18. So int age equals to 18 can be considered as an example for initialization. And instantiation, let me, yeah, instantiation. So the process of creating an object for the class. So when a class is abstract, you cannot create an object for that. So here in animal class, so eat method is concrete and that can be exposed to world. And sleep and run methods are abstract, which are unnecessary and can be hidden. And these definitions are hidden where in subclasses. That is showing the essential things and hiding the unnecessary details. And we are hiding by marking those methods as abstract, and their definitions are provided somewhere down the line in subclasses. So this is how technically we write abstract classes and abstract methods. So we will discuss an example for abstraction, some real-time example. Maybe tomorrow we will discuss because I am late to my office. I have to wind up the session. Do you have any queries in the example which we discussed today? And
This I've got an Eclipse related query. I can ask it tomorrow as well.
Eclipse? Subrato, it was
I've got an Eclipse related query.
okay. Okay.
Is it not clear?
Yeah, now it's clear.
Yeah. Can I ask now or should I ask tomorrow?
Can we take it tomorrow if you don't mind?
Yeah, sure.
Fine. We shall discuss that queries and then we'll follow our session by a real-time example where abstraction is used. Okay? Fine. I'll upload this video recording on YouTube today.
Okay, yeah.
Fine.
Thank you, Hamad.
All right, all right. Okay, Subrata, Mehboob and Ananya, see you tomorrow, same time.
Okay, bye.
Okay, bye.